After learning how a method calls itself in the motivated example, we define a recursive algorithm as an algorithm which calls itself. An algorithm that does not call itself is not called a recursive algorithm. So it calls itself but with smaller or simpler input values of a subtask of the entire algorithm task. For our motivated example, the task was to print on numbers starting from num down to 1. We splitted this task into a subtask which was printing on numbers from num minus 1 up to 1. So our question is how to design a recursive algorithm, or what are the characteristics of a recursive method. So to write a recursive method, you need to know the following. First, you need to know how to split the problem into successfully smaller subproblems. For our countdown problem, countdown 4 was calling countdown 3. So countdown 3 was a subproblem for countdown 4. Next, you need to identify the stopping condition or base case. For how long the method is going to call itself. Eventually, it should stop calling itself. And the condition that makes it stop is called the base case. And you need to know what is the stopping condition or base case for your algorithm. Finally, you need to write the recursive method body using if statement, whose condition is the stopping condition. And this is the structure for the branching that you should do inside the method. You start by testing for the base case or the stopping condition. If it is satisfied, then you solve the local problem and return from the method. Otherwise, you go to the recursive step. In the recursive step, you call the method with a smaller or simpler input. And then after you return back from calling this method, you process the information returned by the recursive calls. Now here in this else statement, the order might change. Now here we are calling the recursive call, then after returning, we are processing the information returned by the call. But sometimes the opposite, like our motivated example countdown. We first print the value of num, this is processing the information, and then we call the method recursively. So it depends on your algorithm. Although Recursion is considered a powerful tool for solving repetitive problems, but it is never absolutely required to solve every problem. There are some problems you can solve them efficiently using repetitive methods, and there are some problems that you can solve them efficiently using recursive methods. So it depends on the nature of the problem. Now, any problem that can be solved recursively can also be solved iteratively with a loop. In many cases, recursive algorithms are less efficient than iterative algorithms. So it depends on the algorithm itself, as we said, and the nature of the problem. There are some algorithms you can solve them efficiently with repetitive methods, and there are some algorithms you can solve them efficiently with recursive methods. So now you know the steps for designing a recursive method. First, you need to split the main task of the problem into a subtask with smaller or simpler input values. Second, you need to identify the base case or the stopping condition. Third, you need to implement the recursive method body by branching or using if with multiple else statements. And you can start this if and else by the stopping condition. Although you know the steps, but that is not enough. You need to explore more ideas. If you fully want to understand how recursive methods are designed, then you need to know how they work. In other words, you need to know how to trace them. After writing your algorithm or after writing your method, how to make sure that your method is given the correct answer? Or how do you know that it is solving the problem that it is assigned to? In the next slides, I'm going to show you how to trace recursive methods. Because every time you call the method, it is going to call itself many times. And after returning from each call, then you have to return back to the previous call. And if there are variables in every call, then you have to keep a track on the state of these variables when you return back from each call.